Hello, everybody, and welcome back to the Science Channel, the Science Experts channel.
Where we bring you uncommon knowledge recorded by uneducated 14-year-olds. And today we're going to be talking about black holes and supernovas and possibly kilonovas. To start off, black holes are these like huge black holes. They're literally black. It's its name. It's a black hole in space. Oh, whoops! My phone just got sucked in from one. You, it's this huge hole in space that has a gravitational force
It's
so large.
it's like, gosh, this could be a black hole, okay? This could be. It's just that it would look like nothing because it would have like the outline of this. It's just that it would look like pure black, the blackest black that you could ever see because no light is reflecting off of it. It's going through the event horizon. They're not holes. They're not physical holes. They have a surface. Jeez.
Anyways, yeah, what Jackson said. So they have a gravitational force of their own, so powerful that not even light can escape it. Everything that's around its event horizon gets sucked in and spaghettified, and it's gone forever.
Not forever. There's a really cool thing called Hawking radiation. And
Oh yeah.
okay, we're gonna get to the realm of quantum physics, which is really cool because Benjamin doesn't know anything. So, Hawking radiation. Just imagine particles, imagine them really hard, and then they're there. So, at a black hole at its event horizon, which is like right here. I'm gonna force Benjamin to put up a picture, but right here is like the boundary between a black hole and around the black hole, like just a couple millimeters in front of the black hole's event horizon, these imaginary particle pairs called antimatter, matter and antimatter, or positron and antipositron pairs, trying to kind of like appear out of nowhere. And then some of the times, like the negative mass and the positive mass particle can situate themselves just enough to where the positive one gets flung away from the black hole and the negative mass one gets sucked in. Therefore, go away. Therefore, it actually loses mass because it's negative mass, which is really cool.
Yeah.
So
I remember you telling me about that now. I remember you telling me about that now. I remember.
So
Yeah.
you could technically say that a black hole evaporates like water.
Yeah. It's not water, it's radiation. Anyways. So yeah, that's a black hole. They're really cool. I honestly, when I first heard about them, which was like I don't even know how long ago, I found them really cool. That's like, yeah. Next we have supernovas. No, these are really cool too. A supernova basically happens when a really powerful, really big star loses its energy or loses its fuel, basically, and it collapses in on itself because of its own gravity and explodes. And it's literally like the explosion is so big that it outshines galaxies, and it's really cool. It's really cool.
So
Yeah.
common misconception that our sun will explode into a supernova. It won't. Not big enough.
No,
It'll
it's not powerful enough.
it will grow into a red giant and then slowly it'll shrink down back into a white dwarf. And as it's doing that, it'll shed off the outer layer. It's gonna shed out its atmosphere, its like first 3-ish layers, and then they'll get shot into space. So um hmm. So think of it like dropping something in water. Like, you know that like sploosh motion where it like drops and then bloosh, sploosh, plop.
Yeah.
So you can almost think of it
Yeah.
like that. The layers going like this and then rebounding and then exploding. So our sun will explode, it'll shed off its outer layers and then kill us all.
Yeah. Supernovas, fun fact, supernovas actually give off more, like, it's so powerful that it gives off more energy than the sun will in its entire lifespan.
Vegeta, what does the scouter say about his power level? It's over 9,000! What, 9,000? There's no way that can be right!
Our sun will in its entire lifespan.
Which is pretty astonishing because our sun has been like around here for about 5
Billions of years. And it's said that our sun will have like a 10 billion year lifespan, I'm pretty sure.
Yeah, so we gotta pack our shit, get our shit straight, and get out of here in like the next 4 billion years. So
5 billion years.
what the
problem? It'll be here before you know it.
So
um next we have kilonovas, which I just learned about. Kilonovas are when two neutron stars basically like come in contact and like hit each other, yeah, and they kind of fuse.
Fusion! Ha!
Why not? He's my...
But it can also happen with a neutron star and a black hole. It's just where they fuse.
Okay.
And I'm pretty sure it also causes some big explosion.
It's called a kilonova. It's so strong that whenever they like start orbiting each other, they like cause gravitational waves, like little waves, like in water, that propagate out. Yeah. And just recently, like a couple of neutron stars like collided and formed a black hole. And whenever that happened, it sent out a gravity. What the hell is your issue, Fly? Go. It sent out a It sent out a gravitational wave that compressed matter. It made like it compressed matter. It compresses and stretches matter.
Correctly!
It These flies are gonna freaking die.
Dead.
They're gonna die!
Ah! Kilonova. Yeah! Big.
Very big explosion. So whenever that happens, stars have these layers. So these layers on the top, there is neutron degenerate matter. And neutron degenerate matter is caused by extreme amount of pressures because matter doesn't really like to be just one particle. It likes to have stuff that balances it out. So neutron,
it likes to be different,
but it's not. It's not different.
Neutrons really want to be protons really badly if they're just by themselves. It's more stable. Think of it like a ball on a hill, and it has like this little cusp right here that prevents it from rolling all the way down the hill.
Yeah.
Pretend that this is a neutron, right? And it's just by itself. Slowly, that's what I freaking thought, Fly. Pretend that this is a neutron, right? And you have a hill that has like one cusp and then another cusp that leads all the way down the hill. And the neutron is right here in a false sense of stability. It can roll down out the hill. It just needs a little bit of a nudge too. So whenever a neutron is left without a pair, that little cusp will slowly start to lower it for simulation's sake. It doesn't actually, and then it just randomly quantum tunnels into a proton because it's way more stable. So eventually, the neutrons on a neutron star, if they came in contact with another neutron star, it would rebound, explode, and then flicker, and then turn into a bunch of new elements like platinum, gold, uranium, thorium, all types of radioactive elements.
Two. So
Anything like right here. Anything right here was made by a neutron star, which is like from gold all the way down. All heavy metals,
yeah.
almost all of the metals are just made.
Heavy metal.
What's the issue?
This is dead for real. I just died. Dead.
But let's recircle back onto stars. So stars, really cool. So stars, really cool. They can come in these classifications right here. It goes from A to O, I think, or A to M. I forgot. Doesn't matter. So we have a K-class star, a K-class clay-cast car.
Hey, that is the best gas station ever made. Circle K is gonna get 85. Like, you can literally, all you have to do is you have to make like a little account. You put in your little phone number. And you get 85-cent drinks for 85 cents. Like, who doesn't want an 85-cent huge drink? I do.
What does this have?
And their food. I like I've tried some of their actual food that's like Circle K makes themselves. And it's not really bad. I'm sorry, this has nothing to do with stars. Circle K. Circle K.
So we have a K-class yellow dwarf star. A K-class yellow dwarf star is a star that is a dwarf. It's not a full-fledged red, like yellow star.
It's a dwarf. It's a dwarf. Oh. Go ahead. Sorry.
It's a star, and it doesn't have enough. It doesn't have enough energy to actually explode into a supernova. So it kind of just like sits around, doesn't really do anything, and then it just like gets really pissed, goes into like this red giant fat ass state, and then it just dies. So we're gonna all die if we don't get out of our solar system and go to a new one.
So, will the sun? So, since the sun is going to expand, how far is it going to be? Like, is it going to engulf our entire like solar system, or is it just going to engulf like to a certain extent and then come back in? Like, will Pluto be okay, or is it just going to engulf everything?
It's going to engulf until about like I'd say about a little bit like below like a little bit before Earth's orbit, like which is like right here, which is like right here, and then it'll shrink down back into like it'll shed out its layers as it's shrinking down, and then it'll be this like tiny little white dwarf right here, and then there's a possibility that as the density of the star is shrinking, the gravity will be less, and so Earth will move out until about at the most Jupiter's orbit, and then as the star like explodes, we would be at a safe distance to where we would not die. So maybe our Earth will be okay, but that is a very, very
that's the thing. I don't know about that because the planet is already hot as shit. It's already fucking hot. Especially where I live, it's like at one time it's like 60 degrees, and then you turn around the next day and it's 110.
Yeah.
So the sun should stay where it is and just not come here. But anyways, not the point. If the sun gets closer to us, the planet would burn up anyways. So I don't think we're gonna survive at all. But yeah,
As
that's just
density
my opinion.
increases, the temperature of it decreases as well. So Earth's climate would actually get colder.
As the sun gets closer.
Yeah. Well, as it expands and it takes up a larger like room in the solar system, it's gonna cover about like I bet it's gonna be like about the size of a beach ball. Like if you're standing on Earth, it'd be like about the size of a beach ball, like at arm's length. So
So like in like 5 billion years, if this Earth even makes it to that point, 5 billion years. Um, yeah, we'll be in Jupiter's orbit probably.
hopefully, if Jupiter doesn't go away, like Jupiter, all of the planets and all the asteroid belts and all like the asteroid belt, the Kuiper belt, and then everything else will also expand at the same rate as we are moving. So Jupiter would be about Pluto, and Mercury would be about Earth's orbit, maybe, or possibly Venus. No, Mercury would be gone. Mercury.
Mercury and Venus would be gone completely, engulfed by.
It'll just be us. If we don't go now, possibly, we would probably never make it.
Yeah.
I mean, maybe we could go live on Jupiter's one of Jupiter's moons, maybe. But that's a slim maybe because we're all gonna die.
Yeah, we'd have to take a lot of materials and stuff like that with us to build like domes and stuff so we can actually live there. That'd take a lot of materials. We need a huge spacecraft to carry all that stuff.
No, not really. It's just like you could have the SLS, like 4 of them, and that would probably be enough to affect to hold everything there. Possibly for just like maybe 300 people. And then like you could like individually bring everybody there. Like a group by group by group by group by group. But
Yeah.
that's a dystopian society that I'd like to discuss for another video.
Yeah. So that's about it. Black hole. To sum it up, black holes are these big kind of planet-like things. They're not planets, of course, but they're planet-like. They have their own gravity, and anything that gets sucked in, except for the Hawking radiation thing, can't get out. Not even light.
Yeah.
Supernovas are big explosions when stars lose energy and run out of fuel, basically, and explode because they can't. There's nothing else for them to do.
So neutron stars are really, really, really close to just becoming a black hole and getting pissed. So they're kind of like the teeter-totter, like something like a ball on the edge of a cliff. It isn't quite like close to the cliff, but one strong gust and it's just over.
So that's black holes and supernovas. We learned about kilonovas, which are kind of like supernovas, but just in a bigger range. And it's when it's when two neutron stars or a neutron star and a black hole collide and make a big, big, huge explosion. I think bigger than even a supernova.
Yeah, way bigger. Like you can see it. You can like see it on Earth. It would be as big as the moon.
Yeah. It's really cool, honestly.
Oh.
And then we learned about different types of stars too. And Jackson's not happy with that. All right, guys. Well, that's kind of it. We learned about everything, all the stars, supernovas, and black holes and stuff like that. So next video, we will be learning. We'll probably be either learning about gravity or archaeology.